It's 3 a.m. Suddenly, a radio telescope beeps. The monitor shows a violent, massive burst of energy where it shouldn't be. The scientist spills his coffee, scrambles to hit record, and zooms in on the source, but finds nothing. Just silence. Was this a glitch or some cosmic coincidence? Actually, new research argues that this is exactly what first contact might look like. Science fiction has been preparing us for meeting ETs for decades. Since we can't travel through space yet, we kind of hope they'll come to us. Hopefully in peace without the laser weapons. But astronomers shrug and say this is highly unlikely. So they've built better telescopes and asked a better question. If life exists out there, what would actually jump out on our screens? That brings us to the streetlight effect. It's the simple idea of searching for your lost keys under the lamppost, just because that's where it's easiest to see. Scientists do the same thing with the universe. They catch the stuff that's easiest to detect, not what's most common. This is how the first planets outside our solar system were discovered in 1992. For years, astronomers stared at sun-like stars, hunting for Earth-like planets, and found nothing. Instead, the first exoplanets showed up orbiting a pulsar. When a giant star runs out of fuel, its core gets squeezed into an incredibly dense chunk of matter that spins unbelievably fast. When rotating, it can aim a radio beam our way like a space lighthouse. Every time the beam crosses Earth, we detect it like a pulse. Thump, thump, thump. That's why it got the name pulsar. Turns out it was just spinning, but we kept the name. The timing of pulses stays so precise that it works like a cosmic stopwatch. So when a nearby planet tugs on a pulsar, that perfect timing wobbles. The pulses might arrive a bit too early or a bit too late. That's how astronomers found the surrounding planets. That's the streetlight effect on a cosmic scale. The idea is that we will only notice intelligent life if it does something loud that sets off alarms or breaks some rules. A Columbia astrophysicist named David Kipping gave the idea a name, the Eschatian Hypothesis. Eschaton comes from Greek and points to the end, like the final chapter. The idea is that when we finally find signs of intelligent life out there, it probably won't be during peaceful times. It will be because something went wrong. Some one-of-a-kind situation for them. A moment so loud it rips through the background static of the universe and reaches all the way over here. Calm civilizations don't show up on radar. A world that runs on clean energy and keeps its tech quiet could last a million years, and we'd never know it was there. But what if they did something big and messy just to survive? Maybe they fired up a planet-wide laser array to nudge an incoming asteroid off course. Or maybe they're testing some super advanced technology. Whatever the noise, even if it lasts for just a few seconds, it could hit radio dishes across the galaxy like a flare. Yes, all of that sounds like science fiction, but that's exactly why we'd notice it. But here's an interesting question. Have we already detected such a signal? There is one candidate that fits this profile perfectly. It remains the most famous unsolved mystery in the history of the search for extraterrestrial intelligence. In 1977, Ohio's Big Ear Telescope caught a radio surge about 30 times stronger than the background, and a volunteer spotted it in the printout. He highlighted the signal's intensity reading, 6EQUJ5, and scribbled down "Wow" next to it, which is how the event got its popular name. The signal lasted exactly 72 seconds. This duration is significant because it matched the time it took for the Earth's rotation to scan across that specific point in the sky. The signal didn't fade away. The telescope simply looked past it. However, when astronomers returned to that spot, nothing was there. They've listened for nearly 50 years, but the signal never repeated. In the science world, things that can't be repeated usually get tossed aside as mistakes. It's important to be careful because false alarms happen pretty often. There's a famous false alarm that still makes astronomers cringe. At the Parkes Observatory in Australia, telescopes kept picking up weird, chirpy signals starting in the late 90s. For 17 years, nobody could figure them out. People blamed lightning, space weather, and space invaders. But in 2015, they all figured it out. The strange signal was coming from the microwave in the break room. If a hungry scientist pulled the door open before the timer hit 0, it leaked a tiny burst of radio waves that looked exactly like a signal from deep space. 17 years of mystery for a disappointing reveal. But the WOW signal didn't behave like that. It didn't look like a satellite, a plane, or any kind of interference, and they definitely made sure it wasn't a kitchen appliance. It came from deep space, near the constellation of Sagittarius. If we apply Kipping's Eschatian theory, this might be what we need to prove life outside our planet. The WOW signal could have been an engine flare from a colony ship trying to escape a disappearing world. Or it could have been a rare natural radio event that just happened to hit us at the perfect moment. The WOW signal grabbed attention because it reached us in radio waves. But Kipping's theory also asks, what if a civilization gives itself away in a completely different way, not with sound, but with pollution? Clues that technology, not nature, caused something are called technosignatures. Think of them as leftover traces. If you walk into a house that smells of fresh paint, you can assume someone was there recently. Astronomers use the same logic with planets. They scan distant exoplanet atmospheres for chemicals that shouldn't exist naturally. The biggest target is a family of chemicals called CFCs. For decades, humans filled the air with these gases because they were cheap and useful. We used them in spray cans and cooling systems, until scientists realized they were bad for the ozone layer. That's why CFCs are such a big deal. Nature doesn't make them. These chemicals are 100% artificial. So if we point a telescope at a distant planet and find its air is full of CFCs, it would be the vital clue astronomers have been waiting for. It could mean someone intelligent is down there, and they're polluting their world on an industrial scale. Besides radio waves and chemistry, you might be able to spot a civilization if they're doing something cool with light. In 2015, astronomers watching a star about 1,400 light-years away, nicknamed Tabby Star, noticed something that seemed impossible. When a Jupiter-sized planet crosses a star, it blocks about 1% of the light. But this star suddenly dimmed by 22%, and it wasn't one clean dip either. The brightness kept plunging in weird uneven chunks with no tidy, repeatable schedule. That's something huge getting in the way. For a brief moment, scientists hoped for a Dyson swarm. That's a hypothetical megastructure made of solar panels and wrapped around a star to capture its energy. Sadly, later studies leaned toward dust clouds instead, but Tabby's star still grabs attention. We keep asking, where is everybody? But for decades, we could only watch a tiny slice of the sky at a time. That's about to change with telescopes like the Rubin Observatory that will sweep the entire southern sky every few nights, over and over, like a giant security camera for the universe. If something flickers, flashes, or suddenly vanishes, we won't just get one blurry screenshot, we'll have the replay. Finally, what if we are the loud ones? We tend to think Earth is noisy because of our TV shows and music, but those signals fade fast. Our real scream is planetary radar. We blast massive radio beams into space to map asteroids. Some researchers estimate that these shouts could be detected from as far as 12,000 light-years away. That's very far. But in space terms, it isn't even the backyard. If we really want to get someone's attention, we need to get way louder. Astronomers detected something strange happening in the darkness of space. They picked up a series of bizarre, unexplained signals coming from distant stars in the Ursa Major constellation. And literally no one can explain their origin. Is it some unknown natural phenomenon or something far more mysterious, more artificial? Let's explore this latest space discovery, the science behind these signals from space, and what scientists believe might be sending them. So, scientists picked up two identical bursts of energy coming from deep space. They weren't random and they weren't background noise. They seemed to be precise and even kind of purposeful. The signals came from the constellation Ursa Major. It lies about 100 light-years away from our planet. The star emitting those signals is called HD 89389. It's a little bigger and brighter than our Sun, but nothing too unusual. That is, until 2023. That's when NASA scientist Richard Stanton noticed something he'd never seen before. The star suddenly flashed, getting bright, then dim, then bright again, and it happened in just a few seconds. There were two identical pulses, exactly 4.4 seconds apart. According to Stanton, the star's behavior was beyond strange. The changes in brightness were far too powerful to be dismissed as random noise or the result of turbulence in Earth's atmosphere. A star over 1 million miles wide doesn't simply fade in and out like that. For a star to just blink out like that in 1/10 of a second is not the kind of thing science can explain easily. But it got even more curious. And the more scientists looked, the stranger it got. Apparently, this wasn't just a flicker, it was deliberate. It looked like something made that light change. But what could it be? It was a truly deep space mystery. So for the next 2 months, Stanton worked a lot. 1,500 hours of total observation time, checking every possible explanation. He compared the data to lightning strikes, airplane reflections, meteors, and even software malfunctions. And every single time, the result was the same. Nothing matched. That's when the research team had to admit what no one expected. Apparently, they couldn't rule out the possibility that those pulses might be artificial. The thing is, after checking every possible explanation, Stanton realized that their space telescope discovery wasn't something anyone had seen before. It couldn't be explained as static, it wasn't lightning, and it definitely wasn't a passenger plane flying by. But it reminded him of something. You see, back in 2019, astronomers detected another strange double pulse. This one was coming from a hot gas giant called Dimidium, about 50 light-years away from Earth. At first, experts laughed it off and blamed it on birds flying through the telescope's field of view. But the new signal didn't seem like one of those simple mix-ups. So, Stanton kept digging. He looked at everything and concluded that a shockwave in Earth's atmosphere could explain the signals. But that idea didn't quite fit. For all 3 pulses to sync up that perfectly, the timing would have had to be almost impossible. The researchers also looked into other possibilities. Maybe the light was bent by some far-off object in our solar system. Maybe a satellite or asteroid partially blocked it. Or maybe it was caused by refraction or even gravitational waves. But none of those theories really made sense either. Some details were clearly missing for astrophysicists to explain how a star could blink that fast and that cleanly. For now, Stanton believes the only way forward is to study all 3 known events more closely and see which explanations still hold up. You're probably asking yourself, how was this astronomy discovery even made? It started more than 60 years ago. That's when scientists officially kicked off the search for life beyond Earth. They called it the Search for Extraterrestrial Intelligence, or SETI. The pioneer of this undertaking was something called Project Ozma. It was led by astronomer Frank Drake, the same guy who came up with the famous Drake equation. This equation is a way for scientists to make an educated guess about how many worlds in our galaxy might have intelligent life that can send out signals we could detect. The idea is simple. You start with how many stars are born in our galaxy. Then you figure out how many of those stars have planets and how many of those planets could support life. Then you gotta figure out how many of those worlds might actually have living things and how many of those might develop intelligent beings. And finally, You try to calculate how many of those might build technology that could let them communicate with other civilizations, like ours. Now, the equation isn't really meant to give a clear number. It's more like a big thought experiment that helps scientists consider all those different pieces needed for life to exist and be noticed in the universe. Anyway, back in 1960, Drake and his team pointed a giant 82-foot radio dish at two nearby stars, Epsilon Eridani and Tau Ceti, and listened for anything unusual. Between April and July of that year, the observatory in West Virginia stayed tuned in, waiting for a signal from the stars. Unfortunately, nothing came through. But the project became the starting point of everything that came after. Since then, scientists have carried out dozens of similar searches using all kinds of wavelengths and technologies to find signs of intelligent life. These days, we call them technosignatures. And while no one's found solid proof yet, there have been a few moments where even experts couldn't rule out the possibility that something, or someone, might be out there. That's where Dr. Richard Stanton comes in and makes the shocking space discovery. Stanton is a NASA scientist who worked on some of the most iconic missions like Voyager and Grace. The latter was a project by NASA and the German Space Agency, where two satellites flew around Earth together, side by side. By watching how the distance between them changed, scientists could see how Earth's gravity shifted in different places. That helped them learn about things like melting ice, ocean movement, underground water, and even climate change. But after retiring, Stanton took on a personal project, searching for intelligent life from his own Shea Meadow Observatory in Big Bear, California. Using a custom-built telescope and a photometer he designed himself, Stanton spent years scanning more than 1,300 sun-like stars, not for radio signals from space, but for flashes of light. Unlike traditional SETI studies that focus on radio waves, Stanton's approach, called Optical SETI, looks for laser-like pulses, sharp, quick bursts of light that could be used for communication across the stars. This idea actually goes back to the early 1960s, when two scientists suggested that advanced civilizations might use incredibly powerful nanosecond laser pulses to send visible signals that could outshine their own stars. For this study, Stanton didn't scan huge portions of the sky. Instead, he focused on one star at a time. He was staring at it for an hour straight and recording its light at incredibly tiny intervals, just 100 microseconds apart. That's fast enough to catch flashes less than a blink of an eye. Then he analyzed the data, searching for any strange repeating patterns and unexplained signals. And eventually, his efforts paid off, and he made the very space discovery we talked about. A sun-like star, about 100 light-years away in the constellation Ursa Major, sent two fast, identical pulses of light. So far, these signals remain unexplained. No one knows for sure what caused those perfect twin pulses. We can't even figure out how far away the source really was. Was something passing in front of the star? Or was the light itself being changed by something we don't understand yet? What we do know is that something strange is happening out there in Ursa Major. Maybe it's a new kind of cosmic event. Or maybe it's something else entirely. And one day, we'll crack this deep space mystery.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, the signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles and light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom! We've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future. Now, don't be nervous, but there is a hole in our universe. Is it leaking? It's larger than anything we've seen before. The human mind can't even imagine something this huge. Well, mine sure can't. Is it a growing black hole? Is our solar system going to end up sucked into this giant nothingness? Am I blowing this all out of proportion? Well, let's figure it out. The universe isn't packed evenly with stuff. Huge empty areas, called voids, make up about 80% of it. Our own Milky Way even sits inside of one, known as the local hole. But one void is on a whole different level. It's called the Behoudy's Void, and people often nickname it the Great Nothing. It's a massive, almost empty bubble of space located far away in the Behoudy's constellation. Its sheer size makes this bizarre formation unbelievable. The Behoudy's Void stretches a whopping 330 million light-years across. For comparison, our little solar system has a width a bit more than 3 light-years. Yet the Behoudy's Void contains very few galaxies. Compared to the rest of the universe, it's basically empty. That makes it one of the largest known voids, and one of the biggest empty spaces we've ever found. If our galaxy were inside the Behoudy's Void, we wouldn't have seen any other galaxies for most of history. Until the 1960s, our telescopes just weren't powerful enough. Other galaxies would have been way too far away and too faint to spot. It wasn't until the 1960s, when telescopes got much better, that we could finally see very faint, faraway galaxies. If we had been living inside that void, that's when we would have first realized other galaxies even existed at all. But let's figure out a very important question. How do such giant empty spaces even form? After the Big Bang, all the matter in the universe started spreading out, but it didn't spread out perfectly evenly. Tiny random differences, called quantum fluctuations, meant some areas had a little more matter than others. The denser areas had stronger gravity, so they pulled in even more matter. Over time, this left other regions almost empty. That's how galaxies clumped together, and how huge voids were created in between. So over time, galaxies attracted each other too, linking up into long thread-like structures called filaments. Together, those filaments formed a massive foam-like web across the universe. The galaxies gathered along the threads, while the empty spaces in between became voids, kind of like bubbles in foam. Smaller voids slowly merged into bigger ones, which is how enormous regions like the Behoudy's void formed. Today, filaments and voids make up the largest structures in the universe. The filaments are hotter and more energetic, while the voids are colder and much emptier. Now, the Behoudy's void is enormous. It makes up about 0.35% of the diameter of the entire observable universe. But inside this massive space, there are only about 60 galaxies, mostly stretched out in a tube-like shape through the center. Normally, a region this size would contain around 2,000 galaxies. The void is also surrounded by massive galaxy clusters, like Ursa Major, Shapley, Hercules, Corona Borealis, and Behoudy's. This makes the emptiness in the middle even more shocking. Now, scientists first noticed those huge empty spaces and big galaxy groups in the 1970s, when new technology finally let them see the universe in 3D. As for the Behoudy's void, it was discovered in 1981 by American astronomer Robert Kirshner from the University of Michigan, which also has a pretty good football team. At the time, he and his team were mapping the universe in 3D by measuring how fast galaxies were moving away from us. This method is called a redshift survey. So while doing this, they noticed something weird, a huge region of space where almost nothing showed up. It was basically a giant blank spot on the map. Scientists ruled out a few dramatic ideas right away. The Behoudy's void isn't a black hole because it does contain a small number of galaxies, just far fewer than expected. It's also not a dark nebula, which is a dense cloud of gas and dust that blocks out light. The Behoudy's void isn't hiding galaxies. There simply aren't that many to begin with. The Behoudy's void helps scientists learn how the universe changes and grows. Because it's so empty, it's a great place to study dark energy. Our universe consists of normal matter, and dark energy. Normal matter is everything you can see with your own eyes or with the help of instruments. It makes up around 5% of the universe. About 27% of the universe is dark matter, and dark energy takes up around 68%. It's a force responsible for the expansion of the universe. We really don't know what dark energy is, so scientists are excited about any chance to study it and learn more about how it works. Voids are also useful for studying neutrinos, tiny particles that can travel throughout space without getting stuck. They're often called ghost particles because they're almost impossible to catch. They fly through space and through us without leaving a mark. Right now, trillions of them are passing through your body and you don't feel a thing. Neutrinos are made in places with lots of energy, like the sun, exploding stars, and nuclear power plants. They are everywhere, second only to light particles in the universe. What makes neutrinos really strange is that they can change as they travel. They come in 3 types, and they can switch between them while moving. Scientists also don't know how much neutrinos weigh, or which type is the heaviest. Learning more about them could help explain how the universe works. Well, anyway, with time, space missions will look closely at these empty regions. By comparing what they see with computer predictions, scientists hope to learn more about neutrinos and better understand how the universe works. One of such space missions is Euclid. Its data will be used to study and analyze the Bohodi's void and other similar cosmic voids. Euclid's job is to study the dark universe. It does this by making a huge 3D map of space, looking at billions of galaxies as far as 10 billion light-years away and covering a big part of the sky. Now, scientists know that dark energy makes the universe expand faster, and dark matter helps galaxies form and stick together. But they still don't know what either of them really is. By watching how the universe has changed over the last 10 billion years, Euclid helps scientists understand how space grew, how galaxies formed, and what dark energy, dark matter, and gravity might actually be like. Euclid is about 15 feet tall and 12 feet wide. It has two main parts. One part runs the spacecraft, like power, computers, and steering, and the other holds the telescope and two cameras. One takes pictures in visible light, that's what our eyes can see. The other sees in infrared light, which helps scientists spot very distant galaxies. Now, Euclid launched on a SpaceX Falcon 9 rocket from Florida in July 2023 and officially started doing science in February 2024. It now orbits far from Earth, nearly 1 million miles away. It stays in a special spot in space where it moves with Earth around the Sun. This keeps its view stable and makes it easier to study the universe. Euclid is supposed to work for about 6 years, but it might keep going longer if it doesn't run out of fuel. In October 2024, Euclid released the first part of its huge map of the universe. Over time, it'll scan more than 1/3 of the sky outside our Milky Way galaxy, capturing billions of galaxies, some so far away that their light took up to 10 billion years just to reach us. The images taken by the space probe are about 4 times sharper than those taken by telescopes on Earth. Euclid also studies light in detail to learn what galaxies are made of and how they move. It'll do this for hundreds of millions of stars and galaxies. And all of this will create a massive space data library, one of the biggest ever made by a space mission. Oh, by the way, Euclid was named after an ancient Greek mathematician who helped invent geometry, the study of shapes in space. Scientists picked this name because understanding the shape of the universe helps explain how matter and energy are spread through space. So now you know.
We've finally found them. Let's go get their planet. A creature stares at the data flashing on a super high-tech translucent screen. Their space station is many light years away from Earth. They were waiting for this signal for a long, long time. They jumped into spaceships and rushed toward Earth, and they don't come as tourists or friends. They are out to conquer. No worries, it's just a hypothetical scenario, but humanity did send a message into space back in 1974. They aimed it at a star cluster 25,000 light-years away. If the message ever reaches someone, they'll know who we are, what we're made of, and creepiest of all, exactly where we live. So why would someone send out such info? Back in the 1970s, the Arecibo Observatory in Puerto Rico had just gone through a major upgrade. The scientists really wanted to show off the power of this massive radio telescope, and they found a way. Instead of just listening out for possible signals from other civilizations, they flipped the script and sent one. The mastermind behind it was Frank Drake, a legendary astronomer known for the Drake equation. It's a formula to estimate how many intelligent civilizations might exist in the galaxy. He teamed up with Carl Sagan, and they created a message in binary code, just ones and zeros, that described humanity. The whole thing was squeezed into just 1,679 bits. Why that number? Because it's the product of two prime numbers, 73 and 23. If you arrange the bits into a rectangle of 73 rows and 23 columns, you get a pixelated picture, kind of like early 8-bit video games. So what exactly did we send? First of all, the numbers 1 to 10. Second, the atomic numbers for hydrogen, carbon, nitrogen, oxygen, and phosphorus, the building blocks of DNA. There was also a rough diagram of our DNA structure, a stick figure of a human. Yep, a stick man. I'm not kidding. Then there was also our average height and the human population at the time, about 4.3 billion. Oh, and they did include the location of our planet in a diagram of our solar system and also a drawing of the Arecibo telescope itself. They aimed the message at Messier 13. It's a huge ancient cluster with hundreds of thousands to millions of stars in one place. Imagine how many prospective planets could be there. The cluster is about 25,000 light-years away. That means it will take 25,000 years for the message to get there and another 25,000 years for any reply to reach us. So, realistically, we won't be getting a new phone who dis text from extraterrestrial creatures anytime soon. The whole thing was meant more as a symbolic gesture, as a way to flex human intelligence and celebrate our tech. Even Carl Sagan says it was kind of like launching a bottle into the cosmic ocean. Sounds cool, but not everyone agrees it was a good idea. Over the years, the Arecibo message has sparked a lot of controversy. Because, here's the thing, what if someone does hear us? And what if they're not friendly? One of the most brilliant physicists in history, Stephen Hawking, famously warned against actively trying to contact extraterrestrial civilizations. He explained that when advanced civilizations have met less advanced ones on Earth, it usually ended badly. And by badly here, I mean horrible things like colonization and many people losing their lives. Hawking said trying to contact some creatures without knowing who's out there could lead to someone coming to raid Earth for resources, then move on. And the famous physicist is not alone here. Plenty of modern scientists argue that sending signals into deep space is reckless. We don't know who's out there. We don't know what they want. And now they know exactly where to find us. The scariest part is that even if we regret sending the message, it's already gone and we can't take it back. It's flying through space right now at the speed of light. Like a cosmic postcard we can't unsend. Since Arecibo, we haven't stopped, but gotten even bolder. In 2008, scientists sent a Beatles song across the universe toward the North Star, which is 433 light-years away from Earth. The song is traveling at the speed of light and should reach its goal in the year 2441. The scientists digitized the song into a data stream, so endless ones and zeros, and blasted it as a radio signal using the DSS-63 dish in Madrid. That dish is about 3/4 as tall as the Statue of Liberty, and it wasn't the first time music traveled into space. Former Beatle Paul McCartney beamed his first intergalactic concert to the International Space Station in 2005 and loved the idea of the new launch. In 2013, some extraterrestrial enthusiasts started a whole crowd-funded lone signal project. The project's beacon was sending tiny 144-character messages, kind of like cosmic tweets, from everyday people on Earth to a red dwarf star named Gliese 526. It's 17.6 light-years away from Earth and it doesn't have any known planets. The message could reach it in 18 years. There was one part made up of a sequence of prime numbers to explain physics and where we are in the galaxy. It had enough clues so that whoever's listening could crack the next part, the human language messages. The second layer was the fun part, the 144-character citizen messages sent from the Lone Signal website. They could be in any language and say pretty much anything. Anyone joining the beaming community could send their first message free, but after that, each new one cost 25 cents. They were hoping to raise $100 million to build a global network of satellite dishes, so we could beam messages all across the Milky Way. But oops, the project ran out of cash just after a couple of months. With our current tech, we could send anything into space, from entire encyclopedias, 3D models, to digital DNA into the stars. But the big question is, who will hear it? And what if they want to wipe us out without even leaving their planet. The wildest part is that some people think some mysterious they have already found us. On the night of August 15, 1977, scientists at Ohio State University's Big Ear Observatory spotted a mysterious deep space signal. It was exactly in the spot where guys from the Search for Extraterrestrial Intelligence organization had been hoping to find something. The signal lasted 72 seconds, was super strong, and then completely vanished. For years, many people believed it was a signal from some unknown extraterrestrial civilization and were hoping to hear from them again. But then, in 2020, scientists spotted mini-WOW signals. Tiny, much weaker versions of the famous 1977 one. Back in the 70s, scientists didn't know about magnetars, those super powerful neutron stars with insane magnetic fields. The original WOW researchers guessed maybe a hydrogen cloud was behind it, but they couldn't explain how it got so loud. Those massive clouds of hydrogen float through space and constantly give off radio signals. Astronomers have been using them for decades to map the shape of our Milky Way. But they're never usually powerful enough to match the WOW signal unless something, like a magnetar, gives them a little boost. It sounds like a really legit explanation for that mysterious signal, but we can't be 100% sure it was that. And just the same way, we can't be 100% sure if the Arecibo message was a brilliant step forward or a potentially dangerous mistake. We won't know for thousands of years, if ever. The Arecibo telescope collapsed in 2020. After nearly 60 years of exploring space, the giant dish fell apart and was eventually demolished. But the message lives on. It's still flying through space across star systems we've never seen. Maybe one day, someone will hear it, and maybe they'll reply with something we've been dreaming about for centuries. You're not alone. Remember that mysterious WOW signal astronomers have been wondering about for the past 40 years? Well, buckle up, because we have some interesting news about it. For those of you who may not know, the WOW signal was a radio sound detected back in 1977 by an astronomer while working at the Big Ear Radio Telescope in Ohio. The signal was so unique and intense that the man scribbled "WOW" in the margin of the data printout, and the name stuck ever since. But what made the WOW signal so special? Well, for one thing, it was never detected again. Despite astronomers pointing their telescopes to that same region of space numerous times over the years, the signal never reappeared. It was like a cosmic one-hit wonder. Now, for decades, scientists have been trying to decipher the mystery behind the WOW signal. Was it a message from an intelligent civilization living outside our planet? Or was it just some random cosmic noise? Years ago, one study claimed that the WOW signal was caused by a comet named 266P Christensen. It was passing through that same region of space back in 1977. And its hydrogen could have emitted a radio signal that just happened to be in the same frequency as the WOW signal. This information was soon dismissed by specialists, who claimed comets don't emit such radio waves. Another theory concerning the WOW signal was that it might have come from a sun-like star. This was based on the idea that the signal was indeed caused by a natural phenomenon, not by little green creatures wandering in space. This star is found in the constellation of Sagittarius at a distance of 1,800 light-years. Now, this distance might sound like a long way, but in terms of the vastness of space, it's practically next door. It was promising because it had some interesting features too. It was very similar to our Sun in terms of temperature, luminosity, and size. Sadly, after studying this Sun twin star a bit more, scientists couldn't pinpoint the WOW signal to it with complete certainty. There may be other stars in the same area that could have emitted the signal. We just don't know for sure. So, what does this mean for the search for life outside our planet through the WOW signal? Well, it means that we're back to square one for the most part. We still don't know what caused the WOW signal, and we don't know if it was caused by an intelligent civilization or a natural phenomenon. One of the ways that astronomers are searching for intelligent life in the universe is by looking for technosignatures. These are signs of technology that we can detect from here on Earth, which could indicate advanced activity in space. They couldn't be explained by natural phenomena. Some examples of technosignatures include laser emissions, radio signals, or signs of megastructures. Today's outer space playlist doesn't end with the wow signal. Get ready to shake those hips and groove to the beat, because we're about to discover black holes and the funky sounds they make. Now you may be wondering, do black holes make sounds? Well, it looks like they do, and it's like a cosmic symphony. First off, let's talk about what a black hole is. It's a spot in space where gravity is so strong that nothing, not even light, can escape its pull. Think of it as a cosmic vacuum cleaner that sucks up everything in its path. Even though black holes don't emit any light, they can still give off some serious vibes. Scientists have been studying these vibes, or sounds, for years, using special instruments to pick up on their cosmic tunes. So, what does a black hole sound like? Well, imagine a bass guitar mixed with the sound of a giant burp. Weird, I know. This sound from black holes comes from the gas and dust swirling around them. As the material gets sucked in, it heats up and emits X-rays, which can be detected by our instruments. These X-rays are like the notes in a song, and they can tell us a lot about what's going in and around the black hole. But here's the craziest part. Scientists have found that different black holes have their unique tunes. It's like they have their own cosmic DJ spinning tracks for the universe to groove to. After studying colliding black holes, scientists have figured out that some are super chill and mellow, while others are wild and crazy with beats that'll make your head spin. Who knows, maybe one day we'll figure out a way to tap into that cosmic beat and use it to power our spaceships. If we can turn sound waves into electricity here on Earth, who's to say we can't do the same thing in space? The mysterious bloop sound baffled scientists for ages too, only this one came from a completely different location, from deep within our Earth's waters. Picture this, you're chilling on your couch minding your own business, when suddenly you hear a loud, eerie noise coming from your speakers. Well, that's sort of what happened to a group of scientists back in 1997 when they stumbled upon the infamous bloop sound. Now, I know what you're thinking. Bloop? That's not very scary. But let me tell you, this sound was no joke. It was a deep, low-frequency noise that lasted for about a minute. And it was picked up by underwater microphones nearly 3,000 miles apart. Naturally, the scientists were like, what on earth is making this noise? Fast forward a few years and the internet is overwhelmed with theories about what could have caused the bloop. Some people thought it was a giant sea monster, while others speculated it was some sort of weird civilization spaceship lurking in the depths of the ocean. And of course, some believed it was just a glitch in the recording equipment. Despite all the speculation, the mystery of the bloop remained unsolved for years. But back in 2005, scientists finally revealed the true culprit behind the spooky sound. Turns out, it was just an iceberg. When icebergs break off from glaciers and float around the ocean, they can make some pretty weird noises. And the bloop was nothing more than the sound of an iceberg cracking and shifting around. Just because we know the cause of the bloop doesn't mean it's any less fascinating. In fact, it's pretty amazing that a sound like that could travel thousands of miles and still be audible. Plus, the fact that it took scientists years to figure out what caused it, it just goes to show how much we still have to learn about our planet. No playlist is complete without a sad, heartbreaking song. And speaking of that, have you heard of the loneliest whale in the world? It's a fascinating story that starts back in 1989, when American specialists were looking for submarines. Instead of submarines, though, they stumbled upon a whale that had a uniquely high-pitched voice, which earned it the title of the loneliest whale. Why is it called the loneliest whale? Well, most blue whales speak at frequencies between 10 and 40 Hz, but this whale's voice is at a frequency of 52 Hz, which is a low bass note to human ears. Since it has a different voice than other blue whales, some scientists believe that it was unable to communicate with other whales. It's also believed that this whale may be a hybrid whale, with one parent from a different whale species. This could cause a different body shape and a different call, which could explain its unique voice. Recent research suggests that the loneliest whale may not be so lonely after all. Many peculiar whale calls have been detected, and some studies suggest that groups of whales living in particular regions have distinct dialects of whale songs that often differ in frequency. To add to the intrigue, later recordings have found that the loneliest whale is now changing its tune. The whale's call has been getting deeper for several years. Maybe it's not so lonely after all and has some whale friends to hang out with.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating. and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere. which is like some sort of a warming blanket that helps maintain the heat coming from the sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there will be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light-years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the Sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive. Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments. Let's take a little satellite, tie it to the shuttle with 12 miles of cable, and send it for a spacewalk. It might sound like another crazy plot for a YouTube hit video, but this idea actually belonged to NASA. In 1996, they teamed up with the Italian Space Agency to try one of the boldest, strangest experiments ever attempted in orbit. The mission was called TSS-1R, short for Tethered Satellite System 1R. They came up with a plan to reel a satellite from the Space Shuttle Columbia on a tether that could carry an electric current. As the shuttle zipped around Earth, that long cable would slice through the planet's magnetic field lines. In physics terms, moving a conductor through a magnetic field generates electricity. So, the Space Shuttle Tether satellite combo was about to turn into a giant orbital power generator. It was like plugging an extension cord into Earth's invisible magnetism. The physics behind this craziness was rock solid. Engineers hoped this tether would pump out usable power, maybe even thousands of volts. If it worked, it could change how spacecraft get electricity or inspire new ways of braking in orbit using electrodynamic drag. So, launch day came. Columbia lifted off. The crew prepared the system, and they started letting the satellite out on its long, long cord. At first, it was smooth sailing. The satellite glided away, the tether unreeled like a spool of cosmic fishing line, and the science team was buzzing with excitement. As the line stretched longer, it started generating more and more electricity, over 3,000 volts at its peak. Everything was running perfectly like a dream experiment. And then, just as the tether was almost fully extended, nearly the full 12 miles, things took a dramatic turn. A localized electrical discharge zapped through the tether's insulation. The cable arced and burned a hole right through itself, and with one fatal snap, the tether broke. Just like that, the grand experiment was toast. The crew could only watch as the little satellite, still trailing its dangling wire, floated off into space like a lost balloon on the world's longest string. Years of hard work preparing the experiment just literally drifted away. Visually, it was almost comical. Reporters couldn't resist calling it the goofiest space experiment in history, and honestly, they weren't wrong. It looked less like cutting-edge space technology and more like someone had tied a toy to a string and let it loose above Earth. But, goofy or not, the experiment actually proved the physics worked. Before the failure, the tether really did generate significant electricity, exactly as the scientists predicted. Over 3,000 volts coursed through that cable before it fried. The idea of using conductive tethers for power and propulsion in space wasn't a fantasy. It was all real. The problem wasn't the science, it was the engineering. Space is an unforgiving place, and one small weakness in insulation was enough to take down the whole mission. Even though TSS-1R ended with a literal snap, it left behind valuable data. Engineers learned more about how tether systems behave in orbit, and the concept is still alive today. Researchers keep looking at space tethers for everything from satellite deorbiting systems to futuristic power stations in orbit. So that broken cable might have been a letdown in 1996, but it wasn't the end of the story. If a satellite on a cable isn't wild enough for you, how about 2 golden orb weaver spiders on the International Space Station? In 2011, NASA sent these 2 cuties, called Gladys and Esmeralda, up there on Shuttle Endeavour, just to see, can spiders spin webs in microgravity? Turns out, yes. The experiment lasted 45 days. While floating in orbit, the spiders went ahead and spun webs, but the webs looked shockingly symmetrical, perfect circles, rather than the slightly lopsided webs they usually make on Earth. The spiders, deprived of down and up, used light inside their habitat to orient themselves. On Earth, spiders use gravity to guide how they stretch their legs and spin out their web lines. But in space, with no gravity to rely on, they looked at the lamps and used that as their ground. But that experiment in 2011 wasn't the first space adventure for spidernauts. Way back in 1973, NASA launched 2 female European garden spiders called Arabella and Anita into space aboard Skylab 3. The idea of this experiment actually came from a 17-year-old high school student in Massachusetts. The spiders were stashed in little containers and then coaxed into a special tank to spin webs while orbiting Earth. At first, Arabella struggled. She took a while to adapt, and the first web she spun was incomplete. But by the next day, she managed to finish it. Over time, the webs she produced were finer and more delicate than normal Earth versions, and scientists noticed subtle differences in thickness across the threads. But NASA wasn't just curious about spiders for the sake of, spiders. Scientists wanted to figure out how near microgravity messes with the central nervous system. Not just in spiders, but in animals in general, humans included. Spiders actually make the perfect test subjects because their webs are basically brain maps in silk. You can tell how well the spider's nervous system is working just by looking at the shape and quality of the web it spins. On Earth, a spider has a whole toolkit. It knows how heavy it is, so it figures out how thick the silk needs to be. It uses wind and gravity to decide where to anchor and how to stretch the lines. But the way spiders adjusted to build webs in 0G gave clues about how our own motor systems and brains might behave if we had to live long-term in space. Sadly, Arabella and Anita, the first 2 spidernauts, did their job, spun webs, gave us tons of data, but didn't survive their mission. The likely cause was dehydration. On a brighter note, scientists have grown everything from lettuce to yeast on the ISS. But one of the oddest was trying to see if fungus could shield astronauts from radiation. They took samples of a fungus that thrives in places with high radiation and monitored how it reduced radiation passing through it. Over a thin layer of this fungal mat, radiation levels dropped by about 2.17% compared to a control sample. At the same time, the fungus had around a 21% growth boost in microgravity. So not only did it block some radiation, it actually seemed to use radiation to fuel itself, almost like a weird fungal solar panel. Now, you might ask, why fungi? Why not steel or lead? Because living things self-repair, self-replicate, and adapt. If you could grow stuff that helps shield you from radiation while it's doing other jobs like repairing and evolving, that's gold for long space missions. The idea is, maybe astronauts could grow part of their radiation shield using organisms, instead of hauling tons of heavy shielding materials into space. There was also broader research catalogs on space fungi and microbes. One study in 2019 cataloged all the bacteria and fungi found inside the ISS, on walls, equipment, windows, sleep stations, you name it. They found the fungal communities were pretty stable over time. That means fungi are not just surviving, but persisting in that closed, harsh space environment. This science experiment is like a hint that we could have a future where biology and engineering mash together. If we can harness fungi or other organisms as part of a spacecraft structure, we open up a whole new way of designing space habitats. Instead of walls you build once, you could have walls that grow. To make radiation levels Earth-like on Mars, you might need a 7.5-foot thick layer of this fungus covering a habitat. That's huge, but maybe easier than dragging tons of lead through space. There's a lot to figure out about safety, control, dose limits, and how this would work long-term. But in the future, astronauts might live behind walls of living mushroom shields, literally harnessing biology to survive the void. You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olbers' paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky, it's not empty. It could be that it's full of light we just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be, but you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them, and a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, isn't it possible someone else did the same, like 150,000 years ago or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature, black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, it disappears behind the event horizon. And then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say, maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models, so it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with two holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways, but in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, yeah, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality, and that's what makes it so exciting. See you next time. A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arecibo, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar, at least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie. Magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stumped. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble Telios, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Telios is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star called a white dwarf starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Telios. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Telios doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Telios might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Telios looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Telios is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Telios' is nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Telios be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about Type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Telios. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be, and none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular Type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Telios can exist, what else is out there, waiting to challenge everything we know about the universe? So this thing, Cosmos 482, a high-tech capsule, was built to survive even the most extreme heat of another planet. But something went wrong. It never made it out of Earth's orbit. For over 50 years, it drifted silently around the planet, forgotten until now. In May 2025, gravity finally pulled it down. It's coming home, built to survive re-entry and unpredictable enough to crash anywhere. No warning, no parachute. Just a 1,000-pound sphere falling from the sky, a human-made meteorite capable of causing chaos. In 1972, this funny-looking ball was sent on a Venus-bound mission. Now, Venus is like Earth's evil twin. It's similar in size, but that's where the similarity ends. It's the hottest planet in the solar system, where temperatures reach 860 degrees Fahrenheit, hot enough to melt lead. Atmospheric pressure is about 93 times greater than Earth's, which is like being 3,000 feet underwater and you feel like you're in a trash compactor. And the atmosphere itself is made of carbon dioxide, with clouds that literally rain sulfuric acid. So yeah, it's pretty bad. Yet Cosmos 482 was fully expected to reach it and land. Not for long, though. A type of self-destruct scouting mission. The spacecraft was designed to land and transmit data, hopefully for at least a few minutes, on the surface that crushes, bakes, and basically dissolves anything that touches it. How? Well, it came with heat shields for the fiery plunge, a mini AC to cool just long enough, and armor tough enough to handle Venus's brutal environment. It was truly a high-tech reinforced vault built for a one-way trip. And this was in the early 70s, mind you. Fun fact, even today, we've never built anything that could survive that kind of environment. We have deep-sea submersibles that can handle big-time pressure, but not the heat. There are space capsules that can withstand extreme temperatures, but only for a few minutes. Even nuclear reactor walls, designed to handle serious pressure, would crumble if acid rained on them nonstop. Now, a funny twist to this story is that landing on Venus was already achieved in 1970. Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth, surviving on Venus's surface for a full 23 minutes before melting down. It proved the impossible was possible, just not for Cosmos 482. So, what went wrong with Cosmos 482? We've always imagined space travel as firing up the spaceship, launching it, and that's it. However, that's not how it works. First, with an initial boost, you park it in Earth's orbit, like pulling into space's driveway. Then comes a second burn, a precisely timed engine firing that pushes the spacecraft out of orbit and toward its destination. Cosmos 482 made it to the parking orbit just fine, but something went wrong with the second push. No push means no trip, so instead of heading to Venus, it got stuck circling Earth for the next 50 years. But why does something get stuck orbiting for so long? Well, when something gets launched into space, it's not just going up. It's also going really fast sideways. If you throw a baseball up hard enough, it'll eventually hit the ground. But if you could throw it fast enough and Earth wasn't in the way, it would just keep falling around the planet. That's what orbiting means, falling but never hitting the ground. The object's forward speed balances perfectly with the gravity pulling it down. So, to leave Earth, a spacecraft needs to pass through 3 layers. The first is low Earth orbit, or LEO, a few hundred miles up. Here is where satellites, the space station, and tons of leftover junk circle the planet. Cosmos never made it past this point. If the second launch had been successful, it would have gone through medium Earth orbit, where GPS satellites cruise. Then, way out at 22,000 miles, there's geostationary orbit, the sweet spot for weather reports and TV. So now we know how Cosmos ended up there and why it was orbiting for so long in LEO. But what made it suddenly change its mind and fall back? Even in LEO, space isn't completely empty. There's still a tiny bit of atmosphere up there, and over time, it acts like a brake, slowing things down just enough. Think back to that baseball you threw sideways fast enough to orbit Earth. Eventually, it will slow down to the point where gravity takes over. However, Earth is securely protected by its atmosphere. As objects fall back to Earth, their speed keeps increasing up to tens of thousands of miles per hour. When you're moving that fast, the air pushes back really hard. That push creates friction, and friction creates heat, a lot of it. The surface of falling objects can reach over 3,000 degrees Fahrenheit, causing them to melt, shatter, or vaporize completely before they ever hit the ground. That's why scientists don't lose sleep over small debris. Small pieces of old satellites, even tools lost during spacewalks, fall all the time. But they burn up like shooting stars. We just never notice them. Now, a baseball would disintegrate instantly. But what about a giant ball designed to withstand landing on Venus? Thankfully, this potentially horrifying story is anticlimactic, because Cosmos crashed into the Indian Ocean west of Jakarta on May 10, 2025. Radar picked it up streaking through the sky, glowing, breaking, heating up, but still intact enough to make it all the way down. And it did, thankfully, not somewhere crowded. However, now that it's lost beneath the waves, we are free to speculate. How real was the danger? Could it have fallen into a crowded area? Absolutely. If that 1,000-pound capsule had come down over a city, it could have smashed through rooftops, wrecked cars, or worse, seriously injured someone. And no, there wouldn't have been sirens or alerts. Cosmos 482 was launched in the 1970s, long before GPS or live tracking, so there was no signal to follow, no proper guidance system. Scientists could only make rough estimates about where it might land, so if it had come down over land, it would have looked like a meteor. Well, the story of Cosmos, with the K, had a happy ending. But it's not the only thing up there that could fall down. As of early 2025, about 11,700 satellites are active. But with roughly 14,900 in orbit, that means over 3,000 are no longer operational. And the space junk keeps piling up. Space tracking systems monitor more than 40,000 objects that are bigger than a softball, such as pieces of old satellites and bits of rockets. Scientists estimate there are over 1 million fragments larger than a half an inch, and more than 100 million smaller bits still floating around. These can't hurt us down on Earth, but most of it clutters LEO, where collisions can generate explosive clouds of debris, damaging satellites and space stations. Just one crash can trigger a chain reaction called Kessler syndrome, where each impact creates more debris, leading to more collisions until Earth's orbit turns into a demolition derby. Remember the movie Gravity? Yeah, like that. And yes, bigger things from LEO do fall. Cosmos 482 wasn't the first space object to come crashing back. In 2016, Tiangong-1 space station lost contact and tumbled back to Earth 2 years later, eventually burning up over the Pacific. In 2001, the famous Mir station was intentionally brought down. And before that, in 1991, Salyut 7, another space station, unexpectedly deorbited. The 40-ton station broke up on re-entry, and parts that survived scattered over Argentina. Among others, in 1979, NASA's Skylab, the very first American space station, fell back to Earth with only partial control. Pieces of it rained down across Western Australia. Some newspapers even offered cash rewards to anyone who found a chunk. So, we've seen this happen before. Cosmos was just the latest reminder. But NASA and other space agencies do think about this problem. And most modern spacecraft designed to return have parachutes, heat shields, and built-in safety systems to guide them home. But not working satellites and old junk. Yeah, they're still up there. So next time, a space object might not land safely in the ocean. It might crash through your roof while you're watching a Brightside video. But don't worry.
Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So, in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things. Really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear. The typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet. This terrifying but very much real image emerged just recently. In it, you can see something that looks like it belongs in a science fiction movie. From far above Earth, aboard the International Space Station, an astronaut captured something astonishing over Louisiana. A gigantic jet blasting upward straight into the sky. It looks as if Earth is sending a signal skyward. Can science explain this eerie phenomenon? Apparently, it can. This energy blast is called a gigantic jet, and it's one of the rarest and most powerful kinds of lightning we know about. Unlike regular lightning, which strikes down toward the ground, gigantic jets shoot up from storm clouds, and they can stretch for more than 50 miles into the sky. Sometimes they even reach the ionosphere, the layer where Earth's atmosphere starts blending into outer space. To give you an idea, space officially starts around 62 miles above sea level, and the ionosphere stretches from about 50 to 400 miles up. Shockingly, scientists have only known about gigantic jets for about 20 years, and we're still figuring out exactly how they work. One theory is that something inside the storm cloud blocks the lightning from escaping downward. So all this pent-up energy looks for another way out and ends up blasting upward into the sky. But honestly, we still don't fully understand why it happens. Gigantic jets are also extremely rare. Scientists think that they happen only around 1,000 times a year on the entire planet. And when they do happen, they carry a lot of energy. We're talking more than 50 times the power of a normal lightning bolt. The strongest gigantic jet ever recorded happened in Oklahoma in May 2018. It was intense, reaching a temperature of 8,000 degrees Fahrenheit and releasing about 60 times more energy than regular lightning. In other words, it was a huge burst of electricity flying straight into the sky. Most of the photos we have of gigantic jets come from satellites or astronauts on the International Space Station. But a few have also been captured from airplanes flying over storms. The latest jaw-dropping image was taken on November 19, 2024, by an astronaut aboard the ISS. At first, the picture wasn't released by NASA or any space agency, but one photographer known for tracking and photographing rare lightning events found the photo by accident. He was browsing through a NASA-run website called the Gateway to Astronaut Photography of Earth, which hosts photos taken by astronauts. There, he spotted images showing a giant lightning jet. Eventually, the photos were brought to public attention on February 26, 2025, and they've also been turned into a time-lapse video on YouTube. We still don't know exactly about the exact spot where the jet happened. Thick storm clouds covered the ground in the pictures. But based on where the ISS was flying at the time, the jet probably happened just off the coast of New Orleans. Speaking of other images of the gigantic jets, a photographer living in Puerto Rico was taking pictures of a storm moving through the area. That same storm would later grow into Hurricane Franklin. While watching the skies, he saw something truly amazing. Several massive lightning bolts shooting straight up out of the storm clouds, stopping just below the edge of space. No wonder. According to a 2022 study, gigantic jets happen most often in tropical areas, and they're more likely during fast-growing storms, like Hurricane Franklin. Gigantic jets often end with thin, red, branch-like lightning tendrils. These faint red flashes are very similar to another rare type of lightning called sprites. Those sometimes look like giant glowing jellyfish in the sky. In 2023, an astronomer named Stanislav Kaniansky in Slovakia captured one of the clearest images of a sprite ever. It happened during a thunderstorm over Central Europe on August 14th, and he spotted it near his home. In the photo, you can see a huge glowing red structure with zigzag patterns stretching over 31 miles across the sky. But like all sprites, it only lasted a fraction of a second before fading away. Sprites happen when lightning sends electrical energy upward into the upper part of Earth's atmosphere, instead of just downward like regular lightning. This energy creates glowing strands of plasma, which is basically electrified gas, way up in the ionosphere. Since sprites are so fast and often hidden by thick clouds, they're very hard to photograph. But Kaniansky got lucky. The thunderstorm was about 200 miles away from him, so he had a clear view just above the tops of the storm clouds. That perfect angle helped him capture this stunning phenomenon. There are many different kinds of lightning, and some of them are not only rare but also super dangerous. Let's take ball lightning, for example. It's exactly what it sounds like, a glowing, floating ball of light that appears during thunderstorms. It's also one of the weirdest and most mysterious forms of lightning. People have seen these strange light balls, usually about the size of a grapefruit, slowly spinning or hovering just above the ground. Some even say they've seen them float through closed windows or suddenly appear indoors, then vanish after about 10 seconds. For hundreds of years, no one really knew what caused ball lightning. Scientists had no explanation, and most sightings were based on eyewitness stories. Then, in 2012, someone finally managed to capture ball lightning on camera. Since then, different ideas have come up to explain what ball lightning really is. One of the newest theories suggests that the ball is actually a tight bubble of super compressed air. This compressed air bends and spins white light in all directions, making it look like a glowing ball rolling around in the sky. And according to the researchers, ball lightning can be almost 1 billion times more intense than regular lightning that moves in a straight line. Then there are elves. They look a lot like sprites, but instead of looking like jellyfish or dancing shapes, elves appear as huge glowing rings or halos in the sky. And they're massive. An elf can spread out to be up to 185 miles wide. You can even spot them from space or through thin clouds during the day. Dark lightning is probably one of the strangest types of lightning, and most people don't even know it exists. Unlike regular lightning, it doesn't produce a bright flash. Instead, it gives off intense bursts of radiation, especially gamma rays, the most energetic form of light found in nature. Dark lightning happens when high-speed electrons slam into air molecules inside a storm cloud. This creates a burst of gamma rays. They're so strong that they can mess with satellites hundreds of miles away in space. In rare cases, when a plane flies through a thunderstorm, these flashes can hit the aircraft. Some passengers could get a quick dose of radiation, about the same as a full-body CT scan. But worry not. Scientists say these occasions are extremely rare and not a reason to be afraid of flying. And finally, there's positive lightning. You see, lightning is still kind of a mystery, even for scientists. But here's the basic idea. Inside a storm cloud, tiny pieces of ice bump into each other and build up electric charges. Some become positive, others negative. Most of the lightning we see comes from the bottom of the cloud, where there are lots of negative charges. These reach down and zap the ground. But sometimes, lightning comes from the top of the cloud, where positive charges hang out. That's called positive lightning, and it only makes up about 5 to 10% of lightning strikes. Most of the time, those positive charges just zap other parts of the cloud. But sometimes, they shoot all the way down to the ground. That's why positive lightning can strike even when the sky looks clear, because it comes from way up high in the cloud, sometimes miles away from the storm itself. The scariest part is that regular lightning can reach about 300 million volts, while the charge of positive lightning can be up to 1 billion volts. That means positive lightning is much stronger and more dangerous. In 2023, an ex-NASA engineer claimed he built a machine that can lift itself against gravity without using any fuel. No rockets, no fire, no exhaust, just electricity. If true, it would break the most sacred laws in physics and rewrite everything we know about space travel. So, is this just another hoax or a door to the future? The engineer's name is Charles Bueller. He used to work for NASA, making sure rockets don't blow up randomly. He was a part of the Space Shuttle, Hubble, ISS, and other huge projects. Now, Bueller and his team work at a private company called Exodus Propulsion Technologies, trying to build a long-term dream of space engineers, a spacecraft that doesn't need fuel. It's the kind of thing that would instantly change everything about space travel. Just think of the future where you could go to the moon, Mars, or wherever you'd like without spending tons of resources. And he claims that he and his team have finally cracked the code. That they've built a machine that can lift itself in the air without any propellant. You got it right. The team claims to have violated Newton's third law, the basic rule of our world that every action needs an equal and opposite reaction. For example, in rockets, you throw fuel out the back, that's action. Being pushed by it, the rocket goes forward. That's the reaction. A magical device like that would also violate the conservation of momentum. When you push on something, you gain momentum, but something else has to gain equal momentum in the opposite direction to balance the books. But this device would change the total momentum of the system out of nowhere. If you're getting motion without pushing against anything, how in the world did you do that? It's like a balloon that can somehow move forward without blowing out any air. If the machine actually works, there must be some new, unknown force of nature that we've somehow missed in hundreds of years of physics. Bueller himself called it the new force. Let's try to figure it out. To create this magical device, they used electrostatics. Their test device was little, a 30-gram object about the size of a card deck, and it managed to create thrust or push using electric fields, a kind of invisible force made by electric charges. The new force starts working when two things happen in the system. The first one is electric imbalance. There's some electric pressure happening across parts of the device, kind of like air pressure. If it's not spread out evenly across it, for example, one side has more electric push than the other, that's the first ingredient. And that happens when the electric field, the invisible force that electric charges create, is set up just right. It has to spread out in a certain way. Not in straight lines, but uneven and fanning out, like sun rays or the spokes of a wheel. And boom, when it happens, the device pushes on itself and makes the whole object move. At first, the mysterious new force was tiny, barely noticeable, little to no thrust and noise. But with each upgrade, things started to shift. And in 2023, they finally measured enough thrust to overcome Earth's gravity. The weirdest part is that, according to Bueller, in some cases, the thrust keeps going even when the power is off, as long as there's still charge left in the materials. That's weird. That's really weird. That hints at something totally new in physics, something deeper than we currently understand. So now, any honest scientist starts sweating, because that sounds bananas, and frankly, it might be. Bueller admits this is still early work. The team published their discovery and got a patent. By the way, the company includes people who've worked at NASA, Blue Origin, and the US Air Force. They've been tinkering with this stuff for decades. Charles presented his findings at APEC, a conference for people who are passionate about alternative propulsion and crazy stuff like warp drives, anti-gravity, and ways to make Star Trek real. Now, they're actively working on that project. Of course, this stuff got very controversial, and lots of scientists are skeptical. There might be a mistake no one has caught yet, so they want to test the machine in space. If it works out there too, it could change space travel forever. It might be real, because it's not the first time we've discovered something like this. Recently, a startup called Evo Limited claimed that they'd built a quantum drive, another propulsion device that apparently didn't need fuel. They said they're tapping into a weird controversial theory of physics called quantized inertia. It was cooked up by a British physicist named Mike McCulloch. He basically said that inertia, the thing that makes objects resist acceleration, isn't a basic rule of nature, but an effect caused by some weird quantum radiation at the edge of the observable universe. In simple words, if QI is right, then under the right conditions, you might be able to generate thrust without throwing anything backward. You don't need fuel, just electricity and a clever enough setup. Many scientists don't buy into it, but who knows? Maybe that's why these new inventions could actually work. Anyway, initially, the IVO company was founded by a small team of tech guys who wanted to find wireless power. Their first big idea was called CBAT, capacitive-based aerial transmission. Basically, a fancy way to wirelessly send electricity through the air. But somewhere along the way, they pivoted. They started wondering, if we can move electricity through the air like this, can we move objects too? Can we rethink inertia itself? So, in 2021, they began working on a propulsion device based on this quantized inertia theory. They built the quantum drive around this idea. It was a self-contained electric system. No fuel tanks, no combustion. Just a plug-and-play box that makes spacecraft move. They said it's light, stackable, and can be bolted onto a satellite like a toaster. And it weighs just a few hundred grams, way lighter than traditional thrusters. In 2023, they tested it, not in someone's garage, but in a legit vacuum chamber, simulating space conditions. The team said they ruled out every known force that might explain the results, and that it did generate thrust, not a lot, but consistent and measurable. Then came the big moment. IVO and a partner company, Rogue Space Systems, launched the quantum drive into space, and now they're waiting for the results of the tests. A lot of physicists think it's all nonsense. Some of them notice that this stuff is impossible because they'd be perpetual motion machines. Basically, if a device like this actually worked, you could use it to make infinite energy, which violates the first law of thermodynamics. But IVO says they're not doing that. They say QI works within our normal Newton's laws, just a bit differently. Anyway, all this stuff needs double-checking. Skepticism is so right because a lot of people get some unpleasant flashbacks. In 2001, a British engineer named Roger Scheuer introduced the M drive. It was this weird cone-shaped device that supposedly created thrust without pushing anything out the back. People were super excited. NASA even tested it with their EagleWorks team, and in 2016, they said they've detected tiny amounts of thrust from the M drive. The media absolutely blew up. People and scientists were hyped up, but later, bigger studies, including one from a German university that really went deep, found the sad result. It was just an experimental error. By 2021, the verdict was in. The M drive didn't work. It was all experimental noise, misunderstood data. Another dream went down the drain. Many propellantless designs have crashed into one huge stubborn wall, the laws of physics. So it's too early to say that these startups just changed the world forever, but if it turns out to be real, it's not just a new engine, it's a new era.
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right. NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays, and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love, and it's an exceedingly small part. So, you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So, when we say, banana is yellow, it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So, the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great, in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on the planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take. Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called loneliest CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.